It's now been a couple of years since I installed the NE0U EZ-J antenna, so it's time to do a little review on what I've found with this antenna, how it's performed for me in that 2-year time period. One change I did make was I removed my 80-meter dipole. The sport lines are still there, so it can be raised at any time, but I did remove it because I wanted to reduce any type of interaction it may have had with the EZ-J, and on 80 meters I prefer vertical polarization for DXing versus horizontal polarization for stateside work.
When I first installed the EZ-J in November of 2021, I originally sent up 135 feet of the Carroll test probe wire, which I nicknamed the Smelly because of the strong rubber odor it has. And I trimmed that 135 feet to tune, ending up somewhere around 128 feet. That 128 feet brought me an SWR dip QRG around 1830 with a match of about 1.3 to 1 or so. Now, the SWR was not a flat match like my EZL as shown in this illustration here. Notice the level horizontal section, which I believe acts as a capacity hat. Now let's look at an illustration of the EZ-J. You see this is more of a folded monopole design, or a J shape, or EZ-J as I call it, and thus no horizontal section. Nevertheless, that SWR seemed good to me, so I ran with it. However, a few weeks later, the SWR dip QRG shifted upwards. I have learned that colder temperatures can cause this situation, as the supporting trees go from a conductor to an insulator. In fact, I produced a video on this subject, which is linked below, and you see a thumbnail of that displayed on your screen. In a cold weather climate, it is best to leave a tree-supported wire antenna a little long if the install is done during warmer weather. So similar to the video on your screen now when I tacked on additional length to the driven element of the EZL, out into the cold and snow I went, and yes, I do antenna work when it's 6 degrees below 0 Fahrenheit. In those conditions, I added more wire to the driven element of the EZ-J, and correspondingly, the SWR QRG dip lowered, and I figured all would be good. However, sometime after that, the SWR dip lowered even further in frequency, below 1800, which is outside the band. Then a week or so later, it jumped back up again. In this time, the EZL remained steady, but the EZ-J couldn't decide what SWR dip it wanted to maintain. Those of you who watched the Good Lesson for Antennas and Trees video might remember this clip.
In your picture is the NE0U EZ-J 160-meter antenna. We just haven't figured this antenna out yet, but as soon as I get something more concrete, I'll do an update video on that.
The reason for the uncertainty in my voice and the reason for a delay of over 2 years to do a follow-up video for the EZ-J was because of these fluctuating SWR issues. Some of these swings were dramatic. I'm talking a difference of 7 feet or more of the driven element. This baffled my antenna people, including NE0U, and no one had any answers. At one point, I even considered scrapping the EZ-J. These cycles kept happening, so I monitored them very carefully, making log entries of the SWR data. And almost by accident, I discovered that the changes were occurring when there were shifts in the outdoor ambient temperature. If the temperature stayed relatively stable, there was no real change in SWR. If there was a big swing in temperature, there was then a swing with the SWR. And this has been going on for 2 years. Simply put, as the ambient temperature lowers, the EZ-J becomes electrically shorter, and the SWR QRG dip rises in frequency. As the ambient temperature rises, the EZ-J becomes electrically longer, and the SWR dip QRG lowers in frequency. So why is this happening? Well, it cannot be the 80-meter dipole because it's no longer installed. Some suggested that it could be interaction with the EZL, which is across the yard, but at times that antenna has been down and the EZ-J still has the changes. Could it be the folded monopole design? Could it be tree interaction? The Carroll test probe wire itself? I don't know, but at this point, quite frankly, I don't care, because I found a way to keep up with these changes and keep the EZ-J on the air. The solution is a very simplistic one and borders on the redneck side. It's the Rapid Extension Deployment System, or REDS. I have a male banana plug attached to various lengths of wire right here, depending on the length required for the optimal SWR, and the driven element has a female banana plug on it. And all I have to do is unplug this, plug in the proper length,
attach that to the feed point, and I'm ready to go. Eventually this will corrode and need to be replaced, but that's a simple job. Just come out here and solder another one on. To lengthen the EZ-J, I just gently pull on the support line until the EZ-J reaches the desired length. Every time I lengthen or shorten the EZ-J, there is some friction that goes on at the apex at 78 feet. The Smelly is not all that durable, so eventually it will need to be replaced. One issue that I have with the Reds, as shown in this example here, is if snow or ice land on the area of the tree where the wire is resting, this becomes frozen and it will not move. And I have to wait for warmer temperatures in order to change the length of the driven element. The Red system, although very redneck with just using a banana plug, seems to handle the power just fine. I've run full legal limit 1500 watts here in the United States of America with no issues.
It's lawn day, Sheila, and the leaves are piling up.
Bit of an eyesore,
I'll say.
Here's a look at one of the 2 ground radials, which I'm still sticking to just 2. It's better to have more, everybody knows that, and no argument against that, but this is a compromised antenna system in the suburbs, and I don't seem to be having problems getting heard, so sticking to 2 for now.
Of course, chasing the perfect SWR is akin to a dog chasing its tail, or in this case, a dog chasing DX, but I'm accustomed to having my antennas operate on the frequencies I desire without the use of an antenna match. So for me, the effort is worth it.
Hey, Meatball. How are you? Oh, you're a little growly this morning, aren't you, huh? Oh, yeah. Probably didn't work Papa Radio Zero Tango and a little growly about it, huh?
Now let's take a look at the performance of the EZ-J. In the past 2 years of casual operating, I've worked 55 DXCC on 160 meters, and that includes some respectable hops such as Japan, Cameroon, Australia, and South Africa. Those of you familiar with this channel might chime in at this point and say, well, of course you did. You have a full legal limit amplifier. And that's correct, I do. However, the 55 on your screen were all worked barefoot with no amplifier. If we want to include amplification, you can add these DXCC, which include some Dannies such as Hotel 4, Kilowatt Hotel 8, Zulu 2, and the very difficult to get Zulu Delta 9. All told, since late 2017 when I first started using the NE0U design, I have 176 confirmed DXCC on 160 meters. Not bad for a compromised suburban antenna with just 2 ground radials. But don't misconstrue my meaning here. My DX Engineering MBVE2 for 40 and 30 meters has 50 plus ground radials, and I would have that on my EZ-J in a second if I could, but that's not possible in my current situation, and the 2 ground radial design is working.
So overall, although not an optimum design, it's a compromise here in the suburbs. The NE0U EZ-J antenna just keeps on making contacts for me on 160 meters, and hopefully it will continue to do so. Thanks very much for watching in 73 from Whiskey X-Ray 0 Victoria. They say there are 2 types of wire antennas in trees, those that have come down and those that will come down. And unfortunately, the EZ-J is now in the latter category. Here it is, laying on the ground. Unfortunately, I lost it, and I'll show you what happened. This is at the feed point, and the Rapid Extension Deployment System also has a fail-safe measure. If the tree sways and it pulls on this, it disconnects, and that way it doesn't break, which is helpful and has happened many times here at my station. However, here's what happened in this situation. The antenna disconnected and the wind blew the antenna vertically along the support tree. You can see a visual representation of that right here, which is normally fine. I would just grab this and reconnect it. Unfortunately, in this particular case, the extension of the antenna went way up into the tree and was about 50 or 60 feet up. And a squirrel found it and took a bite out of it. And here it is, and now it's got me with the unenviable task of trying to get another support line up 78 feet in this cottonwood. After 3 hours of failure yesterday, this morning I walked out here, looked down at the fishing line, looked at my wrist rocket, looked at the targeted branch, and fired, and got a support line up in the tree 78 feet, almost in the same spot as before, and did it in one shot. So the NE0U EZ-J 160 meter antenna has been resurrected. Perhaps the only amateur radio video in history to feature tree bark as a prop, but it does serve a purpose. For any wire antenna in a tree, I start with 10-pound fishing line. Once that line is successfully placed around the targeted branch, I then move to 30-pound fishing line, because the 10-pound is generally not strong enough to pull up the mast trans support rope. With very minimal surface area, it's super easy for fishing line to traverse just about any part of any tree. But what about your support line or your wire? Here's an exaggerated example of what's happened to me. I'm pulling my line up, everything's good, it reaches the knot, and it gets stuck. So here is my redneck solution to create a minimal profile transition from the 30-pound fishing line up to the mast trans support rope. And it's centered around high quality electrical tape. And I stress it must be high quality. The bargain stuff will not work. I will take one end of the fishing line and I literally tape it to the mast trans support rope. Once that's in place, I will wrap the fishing line around the mast trans support rope in this circular fashion, basically almost weaving it into the support rope. Once you've done that many times, then I will take more electrical tape and carefully wrap that around both the support rope and the fishing line, maintaining as minimal profile as possible. This has never failed for me. It always works. In fact, the fishing line will break before the transition will. Once the mast trans support rope is in place, I use the same process for the driven element wire. I'll tape one end directly to the mast trans support rope. And then I kind of weave it in and out of each other like this. Kind of a weaving pattern for maybe about a foot, maybe a little bit more than a foot, something like that. And I'll pull this like this to not only make a minimal profile, but also to increase the strength. And then I will wrap this whole area with the high quality electrical tape. This has never failed as far as breakage. It will not break. And I've yet to have it not get through the tree bark. And that's the real key here. You want to be able to get it past the tree bark, and it might be very high in the air. In my case, it was 78 feet. So it's not real easy to get good leverage when it's up that high, especially when you're at ground level. But this method works for me. A modification I added was to tether the driven element. Now with the reds, it's designed to come apart in case there's stress on the driven element. And of course what happened last time is the driven element ended up in a tree where the squirrels munched on it. Now this mast trans support rope, about 10-15 feet of it here, is in place now to hopefully keep that from happening next time.
In closing, if I had my choice between an inverted J as shown here on the right or an inverted L as shown here on the left, I would take the L in a second, especially given the SWR issues the J is shown. However, that's not what I ended up with, so I'm making do with what I have, which is the main theme of my 160 meter antenna videos. In this case, my inverted J is a good 25 feet higher than my inverted L, so that's why I chose the J as my primary top band antenna, and it seems to be doing pretty well. That said, I'm not necessarily telling you to try this design, I'm just telling you my story. And when it comes to your own 160 meter antenna installation, I say you should do whatever it takes for you to get the most effective signal on the air. And yes, including adding more ground radials. Thank you very much for watching in 73 from Whiskey X-Ray 0 Victoria.